In this video, you're going to learn how to solve special right triangles. So, you know what right triangles are. Those are triangles with 90-degree angles. And out of all the right triangles, there are two special ones. And what makes them special is that you only need one side length to find the other two side lengths in a special right triangle. Most right triangles, you need two side lengths, and then you use the Pythagorean theorem to find the remaining side. But with special right triangles, since we know the ratios between their sides, we can use those to solve for a missing side just knowing one side. So, on the left, we have a 45, 45, 90 triangle, also known as an isosceles right triangle. So I'm going to use those names interchangeably. And obviously the reason why it's called a 45, 45, 90 triangle is because it has two angles, which are 45, and then the third angle is 90 degrees. And in class, we proved that if you know the side length of an isosceles right triangle is a, then the hypotenuse is going to be a root 2. So, in an isosceles right triangle, the hypotenuse is always a factor of root 2 more than the leg, either leg, because both legs are the same. So, if you know the leg, all you have to do is multiply it by root 2 to find the hypotenuse. Now, that does not mean that the hypotenuse needs to have root 2 as its length. You can have an isosceles right triangle where the length is just 10. It doesn't have to be 10 root 2. So let's say you know the hypotenuse and you want to find the leg now. Well, since you're going from a bigger side to a smaller side, you're not going to multiply, but you're going to divide by root 2. So again, if you know the hypotenuse in a 45, 45, 90 triangle, then you divide by root 2 to find one of the legs. Alright, so those are the only two things you would ever need to do in an isosceles right triangle. Multiply by root 2 if you know the side to get the hypotenuse, or divide by root 2 to get the leg if you know the hypotenuse. So, in the other triangle is a 30, 60, 90 triangle. And the first relationship that we know in a 30, 60, 90 triangle, and it's called that because the angle measures are 30, 60, and 90, is that the short leg, so the short leg is the side opposite 30 degrees, is always going to be half the hypotenuse. So that's, the hypotenuse is the side opposite 90 degrees. So if you know the short leg, all you have to do is multiply that number by 2 to get the hypotenuse. So if your short leg is 7, the hypotenuse is going to be 14. If you know the hypotenuse and want to find the short leg, then, well, you're getting smaller, so you're going to divide by root 2. Now, let's say you know the short leg and want to find the long leg. So don't confuse the long leg with the hypotenuse. The long leg is the side opposite 60 degrees. It's not the longest side, but it's the longest leg. So if you know the short leg and you want to know the long leg, well, the long leg is a factor of root 3 more than the short leg. So you just take the short leg, multiply it by root 3, and that will give you the long leg. And we proved in class why that's true. And if you know the long leg and you want to find the short leg, well, then you divide by root 3. Now notice how there's no arrows pointing directly to the long leg right here and the hypotenuse. That doesn't mean if you know the long leg you can't find the hypotenuse. It just means that there's no one operation that you do to go from the hypotenuse to the long leg or vice versa. If you say you know the hypotenuse and want to find the long leg, then you would first divide by 2 and then multiply by root 3. Or let's say you know the long leg and want the hypotenuse, well, you would divide by root 3 to find the short leg first and then double it to find the hypotenuse. Alright, so those are the only 6 different things you're going to do when you're doing special right triangles. So let's practice them right now. So here is a 45, 45, 90 triangle, and we know that because we know 2 of the angles are 45 and 90, so the other angle would have to be 45 if you subtract those two from 360, or 180 rather, sorry. So if you know this hypotenuse is 12 root 2, then you're going to divide by root 2 to get the long leg. So don't think of it, just the leg, it's not a long leg, sorry. Don't think of it as taking away root 2. Think of it as you're taking 12 root 2 and you're dividing it by root 2 to get x. And then what happens is that the root 2's cancel out, so you just get 12. Alright, your answer might have a radical in it, it might not. So don't think it's going to have a radical in it every time, or it's not going to have a radical in it every time. It's going to vary based on the information that you're given. Let's try a slightly different problem. Now, this is the square with the diagonal drawn. So that means we have two 45, 45, 90 triangles, because the diagonals of a rhombus, and this is a square, which is a type of rhombus, will bisect the angles of the rhombus. So we know that's a 45, 45, 90 triangle. And we know the hypotenuse. So we want to, from knowing the hypotenuse, find the leg. Well, when we know the leg, we multiply by root 2 to find the hypotenuse. Now, since we know the hypotenuse, we're going to divide by root 2 to find the leg. So, notice how it's not 10 root 2, it's just 10. So, in this case, we're going to do it just like we did last time. We're going to put 10 over root 2. And that's what x equals. Now, if you typed it into your calculator, it would give you a decimal answer, which would equal the decimal answer you'd get if you simplified this correctly. Meaning, this is the right answer, sort of, it's just not simplified. So you wouldn't get full credit on a test. So to simplify this, you just multiply the top and the bottom by root 2. So if you multiply across, you get 10 root 2 over 2, which just becomes 5 root 2. And you can always plug those numbers back into the Pythagorean theorem and see if it works, and it should. So let's look at 30, 60, 90 triangles right now. So we have a 30, 60, 90 triangle where the long leg is 9. So the first thing we need to do is find the short leg, because if you remember the second slide that we looked at, there was no lines pointing from the long leg to the hypotenuse. Whenever you know the long leg and want to know the hypotenuse, you got to find the short leg first and then double it to find the hypotenuse, because the short leg is half the hypotenuse. So what I'm going to do to find the short leg first, knowing the long leg, is I'm going to divide by root 3. So let's call this right here y. So y is going to be 9 over root 3. And then we can simplify that by multiplying the top and the bottom by root 3. So this becomes 9 root 3 over 3, which just becomes 3 root 3. Alright, so that's y. Well, if I want to know x now I know the short leg, so I just double it to find x, which is the hypotenuse. So x is going to equal 2 times 3 root 3, which just comes out to 6 root 3. Alright, you only multiply the number in front of the radical. Always treat the radical like it's a variable. So if it was 2 times 3x, you would have 6x. So it's 2 times 3 root 3, so you get 6 root 3. Let's look at one more. And this is a combined isosceles right and 30, 60, 90 triangle. So to figure out x, we first need to find this leg right here that I'm highlighting in red. So that's a hypotenuse of this 30, 60, 90 triangle, which is highlighted in red. And we know the short leg. So to go from the short leg to the hypotenuse, we're going to double it. So we're going to multiply it by 2, and we get that this leg right here, the hypotenuse of both triangles, is 10 root 2. Well, if you know the hypotenuse of a 45, 45, 90, which I'll highlight in green, then you could find either leg by dividing by root 2. So I'm going to take 10 root 2 and divide it by root 2, and I get that x is going to come out to 10, because again, it's the leg of an isosceles right triangle in which the hypotenuse is 10 root 2. So you divide that by root 2 to find the leg, and you get 10. I believe that is all. Yes, it is. Thank you for watching. Email me if you have questions, and have a good one.